Hello everyone, we are presenting the Cognitive Legal Document Analyzer, a transformer pipeline that simplifies and answers questions over legal documents without paraphrasing away their binding meaning. I am Pavitra, joined by Jeshwin and Vanjanathan, guided by Dr. P. Janardhan. Next slide. Legal documents are hard for three reasons. They are long, tens of thousands of words, beyond Bird's 512 token window. They are semantically brittle. Swapping shall for must can flip a binding obligation. And general purpose LLMs hallucinate names, amounts, and dates, which in a legal setting is a liability, not a stylistic flaw. Existing tools are black boxes with no link from answer to source. CLDA is a tri-branch pipeline on one shared ingestion stage. B1 extractive summarization, B2 a 100 label ledger clause classifier, B3 agentic retrieval augmented QA. Our headline guarantee is faithfulness by construction. The compressor's decoder lodges are masked to the source vocabulary, so it is mathematically incapable of emitting a hallucinated token. The UI shows simplified text beside the binding original. Two objectives. One, a summarizer whose output cannot contain hallucinated tokens using a source vocabulary logics, mask plus an extractive QA narrative layer. Two, a hybrid sparse plus dense plus citation graph retriever driving an agentic loop with verb, verbal citations. Headline outcomes 88.5% cross classification accuracy, beating Roberta by 4.4 points, zero hallucinated monetary entities on 75 CUAD contracts, and NDCG at 10 of 88.1 on ledger retrieval. Establishes that legal domain pre-training matters but gives no faithfulness guarantee for downstream generation. We adopt it as our sentence encoder and classifier backbone. 100 label contract provisions with a severe long tail. Publish baselines plateau at micro F1 0.88. We close the macro F1 gap with square foot inverse frequency weighted sampling. Confirms practitioners prefer extractive summaries because they are verifiable, yet no system in their survey enforces non-hallucination, that is the gap CLDA fills. Introduces retrieve then generate, but the generator is unconstrained, so it can still fabricate citations. We replace it with a React agent whose finished tool requires explicit chunk ID citations.
Continuing the literature, Beer Thoughtful 2021. Beer shows that no single retriever dominates across domains and it includes no legal corpus. We rerun their protocol on Ledger and Quad dataset with 95% bootstrap confidence intervals. DPR Karpkin 2020. Dense biencoders are weak on rare term and citation queries, exactly what dominates legal text. We therefore run BM25, BGE, dense, and citation graph, PageRank in parallel and fuse them. React Yao 2023, interleaved reason at observe. The original paper uses LLM calls per step. We collapse this to one call per iteration using native function calling, halving agent latency. ILPCR Fall 2025 validates layered retrieval on Indian statutes, but in statute centric, not contract centric. We port the idea to Ledger and Quad and show it transfers. Now, architecture. This is the end-to-end picture. On the left, a shared ingestion stage, multi-format parsing, hierarchical chunking, and citation graph construction. Then three independent branches. B1, summarization with the constrained compressor. B2, the ledger classifier. And B3, the hybrid retriever feeding the React agent. Outputs converge on a dual view UI that renders simplified text beside the binding. So every claim is one click from its origin. System requirements and tools. Standard developer hardware. 16 GB RAM, 6 GB VRAM, Python 3.10 plus, Fast API backend, React Vite frontend, models, LegalBird for encoding or fine-tuned LegalBird for classification, BGE base for dense retrieval, E5 small as the compressor, Roberta Squad 2 for extractive QA, and Llama 3.1 8B on OLama as the agent. Modules, 12 modules in 4 logical layers. The first, the first 4, ingestion and hierarchical chunking, LegalBird sentence encoding, the ledger classifier at 88.5% test accuracy, and a 4 signal sentence scorer, Fusin centrality, loss salience, uh, cross encoder relevance, and the position prior. Next 4, MMR diversity selection, the constrained compressor or core contribution, the fact audit for money and dates, and the extractive QA narrative layer that grounds every entity in a literal source span. Final 4, the hybrid retriever, the BGE cross encoder re-ranker, the single call REACT loop with sits tools, search documents, regex search, read chunk, expand chunk, read lines, and finish, and the dual view front end with per session Chroma DB isolation.
Now the implementation. This is the core guarantee. Source vocabulary logs its processor, plugs into Hugging Face generation at every decoding step. It sets the logits of every non-source token to negative infinity. So the model literally cannot sample an hallucinated token. The fact audit below verifies money hallucinated is empty, which by construction it always is. Two more excerpts. The score fuses Lex rank centrality, ledger clause salience, cross encoder relevance to the section heading, and lead position prior. Weights 0.35, 0.25, 0.30, and 0.10. The retriever runs BM2.25, BG dense and citation graph page rank in parallel. An intent router sets the weights before reciprocal rank fusion with k equal to 60. The react loop is one LLM call per iteration. The model emits both the thought and the tool call in a single response. A no progress detector breaks the stagnation. Tmax is 8. Below is ledger recipe, weighted random sampler with weights proportional to 1 over root n. Final test scores, accuracy and micro F1, both 0.885 and macro F1, 0.823. Now we'll show the demonstration. So this is how our website will look like. So this is where we have to drop a PDF doc and text file of your rental, lease, any type of legal document. So we are going to use a rental agreement as an example here. This is the main summary. It gives away the key facts at glance, such as the monthly rent in the document, the lease term, and these are verifiable with the original document here. So this is the rent. This is the fixed term of lease. So all of them will be summarized here, and all of the important clauses will be tucked away here. And all of them are uh, directly from the document itself. We are not going to change any words in the important class because they are very important. And finally, this is a RAG module. So if you have any questions other than that, let's say you have a question about um, vehicle management. So what are the terms of vehicle? And every tool call is running locally. The tenants are permitted to keep a maximum of one operable currently licensed vehicle, which we can see from here. So this is the original documents words, and this is what we get from our RAG module. For the result of the React agent, we get an NDCG at 10 score of 88.1. For the summarizer, um, we beat the bar by plus 5.8 rogue 1, plus 3.0 rogue 2, plus 2.1 rogue L, and plus 0.8 bird score. For the classifier, it hits 88.5% accuracy, plus 4.4 points over Robota base, plus 7.3 over bird base. To conclude, CLDA is our knowledge, the only abstractive class legal summarizer with a constructive non-hallucination guarantee, state-of-the-art ledger classification at 88.5, hybrid retrieval at NDCG 88.1, and a UI where every customer-facing fact is one click away from its binding source. Full code, evaluation, harness, and checkpoints are open source. Thank you.